In this video lesson, we will specify the kernel and the range of a linear application T. Look at this image. Consider that T is a linear application of vector space V to vector space E. The set of elements of V whose image is the null vector of E is the kernel of T. The set of elements of E that T can take as its objects vary over V is the range of T. Formally, we have for example, let be the linear application. By definition, we have kernel of T equal to through vector equality in R2, we obtain this system of two linear equations. We can solve this system by the substitution method. So, the kernel of T is always a subspace of the application starting space. Since the generic vector of kernel of T is a free variable, then kernel of T is a subspace of R3 with dimension 1. Considering the same linear application, let's now calculate the range of T. We want the vectors of R2 that have corresponding in R3. This is equivalent to knowing for which U belonging R2 vectors, the equality T of V equal U is verified. Since the rank of the matrix of the coefficients is equal to the rank of the extended matrix, then the system is possible in R2. Then, range of T equal R2. As a last example, consider this linear application that transforms matrices of order 2 into vectors of R2. Let's evaluate which matrices of order 2 that belong to the kernel of T. These equalities translates into a system of two equations and four variables. Determining x and y as a function of z and w, we obtain matrices whose inputs depend on these last two variables. It is therefore a subspace of a matrix of order 2 with dimension 2.